झालं. ओके, तर झिरो पोटॅन्शियल इथपर्यंत होतो आपण. हा आपला त्या दिवशीचा स्क्रीनशॉट आहे. त्याच्यामध्ये आपण न्यूटन पर कुलम म्हणजेच व्होल्ट पर मीटर पर्यंत आलो होतो. ओके, देन व्हॉट इज झिरो पोटॅन्शियल? The nature of the potential is such that its 0 point is arbitrary. This does not mean that choice of 0 point is insignificant. Once we set a 0 point, then every potential can be measured with respect to that reference. So we set the 0 potential conveniently. In case of a point charge or a localized collection of charges, 0 point can be set at infinity. For electrical circuit, the earth is usually taken as 0 potential. Thus, a potential at a point A in an electric field can be defined as amount of work done to bring a unit positive charge from infinity to that point. एकच मिनिट जरा नील, माझी टॅबलेट राहिली आहे खाली, मी आणतो. एकच मिनिट होल्ड.
हो.
Yes. So, zero potential point is considered the point at infinity, and then the potential at any given point can be defined as amount of work done to bring a unit positive charge from infinity to point A. हे डेफिनेशन आपण या आधी पण शिकलो होतो इलेक्ट्रिक पोटॅन्शियल या सत्राखाली. आणि ग्रॅव्हिटेशनल पोटॅन्शियल पण अशाच रीतीने आपण डिफाईन करतो की इन्फिनिटी अंतरावरचं ग्रॅव्हिटेशनल पोटॅन्शियल 0 मानतो आपण, आणि कुठल्याही पॉईंटचं ग्रॅव्हिटेशनल पोटॅन्शियल म्हणजे इन्फिनिटीपासून त्या पॉईंटपर्यंत वस्तूला आणण्यासाठी लागणारा जे वर्क डन असेल दॅट इज the gravitational potential. Similarly, we define the electrical potential at point A. So we can define it, electrical potential at given point at a point. can be defined as amount of work done to bring a unit positive charge done to bring a unit positive charge. Unit म्हणजे 1 coulombचा. A unit positive charge from infinity to that point. So next is one numerical. हे लिहिलं?
हो झालं.
Then potential at point A, and the potential is given 4 into 10 raised to 5 volt. Find a work done in bringing a charge of 3 microampere from infinity to that point. So how do we define the work done? We have the formula V equal to W upon Q, बरोबर की नाही? V equal to W upon Q. So आपल्याला वर्क डन विचारलाय, तो वर्क डन इज इक्वल टू V इंटू Q. So V किती दिलाय आपल्याला? V is 4 into 10 raised to 5, म्हणजे 4 lakh volt, आणि Q is given to be 3 microcoulomb, 3 into 10 raised to minus 6. Okay. That is equal to 12 into 10 raised to minus 1, and that is 1.2 joule. So amount of work done is 1.2 joule. Does the answer depend on the path along which the charge is brought? No. The answer is independent of the path. Whatever may be the path, work done will remain the same. If 120 joule of work is done in carrying a charge of 6 coulomb from a place where the potential is 10 volt to another place where the potential is V, then find the V. इथे आपल्याला W दिलाय work done, and that is given to be 120 joule. Q दिलाय आपल्याला charge, that is given to be 6 coulomb. Okay. Then it is said that there is a point where the potential is 10 volt, and there is another point where potential is V. So we have moved the charge from this point, if we call it as A, to this point, which we can call it as B. What will be V? BA means potential of point B with respect to A. That will be equal to VB minus VA. Okay, that will be equal to V minus 10. Again we can use the same formula. V is equal to W upon Q. VBA in this case. So we can write V minus 10 equal to 120 upon 6. So we can write V is equal to 20 minus 10 इकडे ट्रान्सपोज झाले plus 10 होतील, and that will be equal to 30 volt. So this way we can find the things. So ठीक आहे, इथपर्यंत कळलं?
होय.
Then we will move to the next topic, and that is electrical potential due to a point charge, a dipole, and a system of charges. So first the electrical potential due to a point charge. हे झालंय का रे आपलं? What do you say? नाही, आपण नुसतं इलेक्ट्रिक पोटेन्शियल डिफाइन केलं होतं. एक्सप्रेशन फॉर इलेक्ट्रिक EP, that is delta U. नाही झालं. एक्सप्रेशन फॉर EP झालं होतं. देन कन्सेप्ट ऑफ पोटेन्शियल, येस, सिमिलर आहेत सगळ्या गोष्टी, त्यामुळे परत आल्यासाठी. इलेक्ट्रिक पोटेंशियल ड्यू टू अ पॉइंट चार्ज V is equal to Q upon 4 pi epsilon 0 R. Here we shall derive an expression for electrostatic potential due to a point charge. So we'll consider a point charge plus Q located at point O, and we need to determine its potential at point A, which is at a distance R from it. So we can say that the electric potential at point A is amount of work done per unit positive charge which is displaced from infinity to that point. म्हणजे एक 1 कुलमचा चार्ज हा आपल्याला इन्फिनिटी पासनं पॉइंट ए पर्यंत आणण्यासाठी जेवढं वर्क डन करायला लागेल, that work done will be equal to the potential at point A. Correct. So let us write electric potential due to a point charge. We have a charge of plus Q kept at point O, and we need to find a potential due to this charge at point A, which is at a distance R from that point. Correct. So what do we consider? We consider that we are moving 1 coulomb charge from infinity to point A against this point Q. We'll consider a point M which is at a distance x from the origin, that is O, and again consider a point N which is at a small distance dx from there. Correct. So the potential at point A, VA, if we want to calculate it, it is equal to work done to move unit charge from infinity to A. Correct. To find the work done, we have to find the force acting on that unit charge. So let M be an intermediate point at distance x. The electrostatic force acting on a unit positive charge at M electrostatic force acting on a unit charge kept at M F is equal to, that force is equal to 1 upon 4 pi epsilon 0. ओके नाही, कुलम्स लॉ वापरायचा. 1 upon 4 pi epsilon 0 Q1 Q2. आता Q1 किती आहे आपला? आपला Q1 आहे प्लस Q. Q2 किती आहे? Q2 आहे प्लस 1. ओके नाही, बिकॉज इट्स अ युनिट चार्ज divided by the distance square. Distance किती आहे? x. So 1 upon 4 pi epsilon 0 q upon x square. It is directed away from O. कारण हा रिपल्सिव्ह फोर्स असणार ना, कारण दोन्ही लाईक चार्जेस आहेत. The like charges will repel each other, so the force is in opposite direction. Force is away from O. So that kind of force. For infinitesimal displacement dx of charge, आपण असं कन्सिडर करू की त्या चार्ज या फोर्सच्या अगेन्स्ट आपण डिस्प्लेस केला थ्रू अ डिस्टन्स dx. So consider unit charge is displaced from m to n. Unit charge is displaced from m to n. So it is against the force. So displacement is against the force. So how much is the small work done in the movement? Small work done in the movement dw is equal to minus f dx. Negative sign indicates that f and dx are opposite. ओके नाही, f आणि dx एकमेकांना opposite आहे. So this is a small work done to move the charge from m to n, that is through the small distance dx. Now we have to find the total work done. Total work done in moving the charge from infinity to a. Total work done in moving charge from infinity to a. A म्हणजे काय? A is at distance r. So we can write W is equal to, and we write integration from infinity to r. Infinity to r minus f dx. Then we put the value of f there. That is equal to infinity to r. Value of f is 1 upon 4 pi epsilon 0 minus 1 upon 4 pi epsilon 0 q upon x square into dx. That is equal to minus 1 upon 4 pi epsilon 0 taken outside it. Q can also be taken outside because q is constant. आणि इंटिग्रेशन फ्रॉम इन्फिनिटी टू r मध्ये काय येईल? आता हा x हा वरती गेल्यावर मायनस 2 येईल ना, x raised to minus 2 dx. हो की नाही? And what is x raised to minus 2 dx? Minus q upon 4 pi epsilon 0. Yes, what is integration x raised to n dn? It is x raised to n plus 1 upon n plus 1. Okay, nahi? That is x raised to minus 1 upon, yes. Upon काय? Upon 1 minus 2 म्हणजे minus 1. So it will be minus x raised to minus 1 and it is from infinity to r. Correct? So if we calculate the work done finally, W is equal to q upon 4 pi minus q upon 4 pi epsilon 0. ओके नाही, हा इथला मायनस झाला प्लस, आणि मग ब्रॅकेटमध्ये राहील 1 अपॉन r minus 1 upon infinity. 1 upon infinity 0. So finally W is equal to q upon 4 pi epsilon 0 r, and which is equal to V, the potential at point A. So this is the expression for the potential at any point due to a point charge. So equation shows that for any point at a distance r from a given point charge q, the value of the potential is same and is independent of the direction of r. Hence electrostatic potential due to a single point charge is spherically symmetric. So it will be same all over at a distance r. म्हणजे सगळ्या त्या इक्विपोटेन्शियल पॉइंट जर आपण लोकस काढला दॅट विल बी अ स्पियर. हो की नाही? इथे काय लक्षात काय म्हणतोय मी ते की हा इथे समजा प्लस क्यू आपला चार्ज आहे, तर हे जे आपलं पोटेन्शियल आहे ते आर ला सेम आहे सगळीकडे. सो इथे जसं व्ही असेल पोटेन्शियल तसं इकडे पण ते व्हीच असेल, ह्या इतक्या डिस्टन्सला पण ते व्हीच असेल, खाली इतक्या डिस्टन्सला पण व्ही असेल. मग ह्या सगळ्या पॉइंटचा जर लोकस काढला आपण दॅट विल बी अ स्पियर. ओके नाही? तो स्पियर होईल. म्हणजे हे जर आपण 3 डायमेन्शन मध्ये एक्सटेंड केलं दॅट विल बी अ स्पियर. सो तेच सांगितलंय. सो it is spherically symmetric. So this potential is spherically symmetric.
Okay.
So if we draw the graph of V versus R, तो कसा आहे ग्राफ तो कि V is directly proportional to 1 upon R. So that is shown by the dotted line. And if we find the electric field which is directly proportional to 1 upon r square, so that is shown by the solid line. म्हणजे E versus R हा जो ग्राफ असेल तो सॉलिड लाईन नी दाखवलाय आणि V versus R हा जो ग्राफ आहे that is shown by the dotted line. One is proportional to 1 by r and other is proportional to 1 by r square. A wire is bent in a circle of radius 10 centimeter. It is given a charge of 250 microcoulomb which spreads uniformly. What is the electric potential at the center? So Q is given 250 into 10 raised to minus 6 coulomb. Distance R is given which is 10 raised to minus 1 meter. How much is V? V is 1 upon 4 pi epsilon 0 and you know that 1 upon 4 pi epsilon 0 is 9 into 10 raised to 9. And
yes,
it's approximately equal to means 9 into 10 raised to 9 because the value of epsilon 0 is 8.85 into 10 raised to minus 12. So it is 9 into 10 raised to 9 into Q. Q is 250 microcoulomb, that is 250 into 10 raised to minus 6 and divided by R which is 10 raised to minus 1. So if you calculate it, it comes to be equal to 2.25 into 10 raised to 7 volt. So this is about the potential due to a single charge. Now we can also calculate the potential due to an electric dipole. So we have studied electric and magnetic dipole in 11th standard. Di म्हणजे दोन आणि पोल म्हणजे पॉइंट्स. तर दोन पॉइंट चार्जेस प्लस क्यू आणि मायनस क्यू एकमेकांपासून फायनाइट डिस्टन्स वर ठेवले विच इज इक्वल टू 2L लेट अस से. Then it forms an electric dipole and its electric dipole moment is given as P is equal to Q into 2L, where 2L is the distance between the two charges and which is always directed from the negative charge to the positive charge. Means we define the dipole moment that way. The line joining the centers of two charges is called dipole axis. A straight line drawn perpendicular to the axis is called equator of the dipole. In order to determine the electric potential due to a dipole, let the origin be at the center of the dipole. तर आपल्याला ह्या एका डायपोलच्या मुळे निर्माण झालेलं आपल्याला इलेक्ट्रिक पोटेन्शियल काढायचं आहे. सो इलेक्ट्रिक पोटेन्शियल ड्यू टू अ डायपोल with the origin at the center of the dipole. So how can we calculate that? थोडंसं complicated derivation आहे हे, but if you understand the geometry it will be easier to understand. So first we'll write the heading, and the heading is electric potential due to an electric dipole. Electric potential due to a dipole. So first we will draw a dipole. How can we draw a dipole? Dipole is nothing but two charges of equal and opposite magnitude, plus q minus q, line joining the two. This is the origin. We define the length of the dipole to be equal to 2L. Then we want to find the electric potential due to the dipole at point C, such that the distance of this point C from origin is equal to R. Okay. Now this is, let us say, point A, this is point B, and there are two charges, one is plus q, another is minus q. So we will find the potential due to each point, and then we will find the resultant potential. So this is 1, this is another point. आवाज कसला येतोय?
माझ्याकडनं
हां, तर माझ्याकडनं येतोय.
कसला?
कीबोर्डचा आवाज आल्यासारखा येतोय. R1 and R2 are the two distances. Okay. So the vector p bar, that is dipole moment, is directed from negative to positive. So it is, this vector is in this direction, negative to positive. Distance is 2L. So this distance OA is also L, and this is also L. So what do? We extend this line further and we drop a perpendicular like this, and then we will define something. Then we say, and we also drop a perpendicular from here to here like this, and then we say that the point, this at point O, the angle made is theta. So this is how it is. So let C be any point near the electric dipole at a distance r from the origin. Let C be any point near the dipole at distance r from origin Let distances r1, r2 are distances of C from plus q and minus q. R1 is nothing but distance of C from plus q, and R2 is nothing but distance of C from minus q. Then what we will do? We will find the potentials at point A. At point C due to charge plus Q and minus Q. So we will say VA is equal to VA is nothing but potential at C due to charge plus Q. And how much is that? That is equal to 1 upon means plus Q upon 4 pi epsilon 0 R R1. Okay, 4 pi epsilon 0 R1. And we will also calculate the potential due to charge minus Q. So we will say VB is equal to potential at C due to charge minus Q, which is equal to minus Q upon 4 pi epsilon 0 R2. So the total potential at point C, म्हणजे तिथे दोन आहेत ना पोटेन्शियल, एक तर प्लस क्यू मुळे झालेलं पोटेन्शियल आणि दुसरं म्हणजे मायनस क्यू मुळे झालेलं पोटेन्शियल. सो टोटल पोटेन्शियल VC is equal to VA plus VB, okay, the addition of the two potentials, that is equal to the Q upon 4 pi epsilon 0 can be taken common from both of them आणि ब्रॅकेट मध्ये मग काय राहील 1 upon R1 minus 1 upon R2. ओके नाही. आता इथे आपलं डेरिवेशन संपवायला काही हरकत नव्हती की नाही, झालं मिळालं आपल्याला. But the problem is that we don't want it in terms of R1 and R2. We want it in terms of R. आपल्याला हे R1 R2 मध्ये नको आहे. R1 R2 मध्ये असेल तर इथे संपलं डेरिवेशन, याच्या पलीकडे काही नाही. But if you want to calculate it in terms of R, then we have to eliminate R1 R2 and write the formula in terms of R. So how can we do that? For that we have to do some adjustments. So you have to consider the right angle triangle. If you consider this right angle triangle, which one? This right angle triangle. Then you know that this is a 90-degree angle. A 90-degree angle है, okay, right angle है. Then you can write R1 square sorry, not this, चुकीचा घेतला मी. Now this entire distance is R. This distance is R. This is L. This distance is L. So we have to write R1 in terms of R and L. So how can we write that? If this is angle theta, then how much will be cos theta? Cos theta is this, and if we call it as, that will be divided by L, isn't it? सो इफ याला काहीतरी म्हणूया, याला आपण काय म्हणूया, याला नाव पण नाही घेतली. दिस विल बी एल कॉस थिटा. काहीतरी एक्स म्हणूया त्याला. एक्स ऑलरेडी घेतलाय आपण. काय म्हणूया, वाय म्हणूया. वाय अपॉन एल. वाय विल बी इक्वल टू एल कॉस थिटा. ओके नाही. So this length will be L cos theta. This length. ही L cos theta असेल. And this will be L sin theta. Okay. So this remaining length. This length इथे ब्लू लाइन काढली थी, that will be equal to r minus L cos theta. Okay. Then if you apply this Pythagoras theorem for this shaded triangle, it will give you that r1 square is equal to this side square plus this side square, that is L sin theta bracket square plus r minus L cos theta square. So that is equal to r1 square, that is equal to L square sin square theta, L square sin square theta plus r square minus 2 RL cos theta plus L square cos square theta. That gives you r1 square is equal to L square common काढला, bracket मध्ये sin square theta plus cos square theta, that will be equal to 1 minus 2 RL cos theta plus r square. So sin square theta plus cos square theta is 1, so you get r1 square equal to L square plus r square minus 2RL cos theta. Okay, this is your statement number 1. Similarly, if you consider this bigger right angle triangle, this one, for that what you can write, r2 square is equal to if this is theta, then this is theta, this is L, so this length will be your L sin theta, and again this will be your L cos theta, isn't it? This will be your L cos theta. So r2 square is equal to L sin theta bracket square plus r plus L cos theta आणि ब्रॅकेटचा स्क्वेअर. ओके नाही, समजताय का?
होय.
That will be L square sin square theta, L square sin square theta plus r square plus 2RL cos theta plus L square cos square theta. पुन्हा तो L square कॉमन काढला, sin square theta plus cos square theta is 1, so that will be equal to L square plus r square plus 2RL cos theta. Correct. Finally, we are interested in finding 1 upon r1 and 1 upon r2. So we write r1 square equal to this and r2 square equal to this. So these two statements we can further simplify as r1 square is equal to, if we take r2 square r square common out of this, म्हणजे आपण असं दिलं की r1 square is equal to आणि इथे r square कॉमन काढला, that will be L square upon r square. ओके नाही, r square डिवाइड होईल की नाही इथे, प्लस 1 L square upon r square प्लस 1 प्लस 2L upon R, सॉरी R1 चे ते मायनस येईल, मायनस 2L upon R cos theta, आणि R2 स्क्वेअर इज इक्वल टू, अगेन R स्क्वेअर कॉमन काढला, L स्क्वेअर अपॉन R स्क्वेअर plus 1 plus 2L upon R cos theta. Now there is one more approximation. If R is much greater than L, considering R to be much greater than L, that means dipole is very short in length, dipole is very short in length. Dipole is very short. So in that case, L upon R is very small, and L square upon R square can be neglected. कारण म्हणजे हा जर 10⁻³ असेल, 10⁻³ मीटर म्हणजे किती, 1 मिलीमीटर अंतरावर 2 चार्जचं स्क्वेअर किती होईल, 10⁻6 होईल ना. So that will be very small and that can be neglected. So we can ignore these two terms if the condition is satisfied. मग कंडिशन काय आहे की दोन जे चार्जेस आहेत त्यांच्यातलं डिस्टन्स खूप स्मॉल आहे, खूप कमी आहे, आणि त्या मानाने आपण ज्या पॉइंटला पोटेन्शियल काढतोय ते डिस्टन्स जास्त आहे. इफ this condition is satisfied, then we can neglect L square upon R square. So that gives us R1 square is equal to R square in bracket 1 minus 2L upon R cos theta, and R2 square is equal to R square in bracket 1 plus 2L upon R cos theta. So we have neglected that L square upon R square term. Correct. So you can write R1 is equal to R in bracket 1 minus 2L upon cos theta, 2L upon R cos theta raised to half, and R2 is equal to R into 1 plus 2L upon R cos theta raised to half. But what we are interested is 1 upon R1 and 1 upon R2. So we can write 1 upon R1 as 1 upon R 1 minus 2L upon R cos theta raised to minus half, and 1 by R2 is 1 upon R 1 plus 2L upon R cos theta raised to minus half. So this way we get 1 upon R1 and 1 upon R2. Correct. So now we put these values in value of VC. So VC is, आणि VC आपण काय आधी म्हटलं होतं, Q upon 4 pi epsilon 0 1 by R1 minus 1 by R2 त्यातल्या 1/r1 ची किंमत आपण काढली 1/r 1 मायनस 2l/r cos theta, सॉरी 1/r1 ची व्हॅल्यू 1/r 1 मायनस 2l/r इंटू cos theta रेज टू -12 minus 1/r 1 plus 2l/r cos theta raised to -12. So this is the value. Now here we use the binomial expansion, and binomial expansion is 1 plus x raised to n, means 1 plus x bracket raised to n. What is the binomial expression for that? Binomial expansion 1 plus n bracket raised to n, and that formula is one plus x raised to n. It is equal to, see, you can छोटं दिसत असेल, here you can see it. It is 1 plus nx plus n into n minus 1 upon 2 factorial x square plus n into n minus 1 into n minus 2 upon 3 factorial x cube, etc. up to infinity. So here also again you can see the term is l/r. ही जी term है l/r. So we can neglect the higher powers of n/r and only use the first. So as 1 plus x raised to n is equal to 1 plus nx plus higher powers of n. Here n is l/r. So we can neglect the higher powers of n, and we can write Vc is equal to, we will keep only the first term, that is equal to nx. So it is equal to q upon 4 pi epsilon 0 1 upon r in bracket 1 plus l upon r cos theta minus 1 minus l upon r cos theta. So ultimately it comes out to be Vc is equal to q upon 4 pi epsilon 0 r. This l upon r cos theta minus that is plus l upon r cos theta. So it is 2 lr cos theta, correct, into 2 l upon r cos theta, and this q into 2l is nothing but the dipole moment P, as P is equal to 2ql. We can replace that 2ql by P and write Vc is equal to P upon 4 pi epsilon 0 cos theta upon r square. So this is the value of electric potential due to a dipole.
Yes.
Hence the potential at
जरा लिहितो थोडासा वरती घ्या.
कुठपासनं राहिलाय?
VC इज इक्वल टू तिथपासून आहे.
इथपासनं. ओके, स्क्रीनवर दिसतंय ना म्हणजे? ओके.
हो दिसतंय. झालं.
So if theta is equal to 0, then cos theta will be equal to 1, correct? So potential will be maximum if theta equal to 0. And what do you mean by theta equal to 0? Theta equal to 0 means the point C lies along the dipole. So if cos theta equal to 0, Vc is maximum, and this maximum condition is when the point is along the dipole. Point is along dipole. And if theta equal to 90, that means the point is on the equatorial line, then cos theta will be 0 and Vc will also be equal to 0. So when the point is on along equatorial line, then the potential will be 0. So this is about the electric potential due to a dipole. Again there is a numerical on this. Solve this. A short electric dipole has dipole moment म्हणजे P दिलाय 1 into 10 raised to minus 9 coulomb meter. Determine the electric potential due to the dipole at a point distance 0.3 from the center of the dipole on the axial line, equatorial line, and on line making angle 60 degree with the dipole axis. So let us try to calculate all the three. सो पहिल्या केसमध्ये ॲक्शियल लाईन म्हणजे थीटा किती दिलाय 0, ओके नाही. सो ए साठी थीटा इक्वल टू 0. सो व्हॉट इज अवर फॉर्म्युला? फॉर्म्युला इज Vc इज इक्वल टू P अपॉन 4 पाय एप्सिलॉन 0 cos theta upon r square, ओके नाही. सो Vc here theta 0 म्हणजे cos theta 1. So it is P is 10 raised to minus 9 and 1 upon 4 pi epsilon 0 is 9 into 10 raised to 9 into 1 upon r square, and r is given to be 0.3. So it is 0.3 square. So plus 9 minus 9 gone. It is 3 upon 10 चा स्क्वेअर म्हणजे 9 upon 100. म्हणजे थोडक्यात 100 upon 9 होईल. ते 9 into 100 upon 9, 9 cancel, that will be equal to 100 volt. On the equatorial line V will be equal to 0 because theta is 90 degree.
Yes.
If theta is 90, then Vc will be equal to 0. And if it is 60, then we will have cos 60 equal to 0.5. Okay. For condition C, Vc is equal to P cos theta upon 4 pi epsilon 0 r square, and that is equal to 10 raised to minus 9 into cos 60. Then 1 upon 4 pi epsilon 0 is 10 raised to 9 into 10 raised to 9 upon 0.3 square. So everything will be similar. Minus 9 plus 9 gone. हे 100 येईल. 100 cos 60. Cos 60 is 0.5. So that will equal to 50 volt. सो इन ऑल म्हणजे आपल्याला काय सांगितलं आहे की एक डायपोल आहे की त्याचा डायपोल मोमेंट दिला आहे आपल्याला प्लस क्यू मायनस क्यू दिला होता. डायपोल मोमेंट त्याचा होता 10 raised to minus 9 coulomb meter. So one was along the axis, second was along the equatorial point इथे होता, आणि तिसरा होता along 60 degree angle इकडे होता. सो तिथे आपण या सगळ्या गोष्टी शोधून काढल्या. ठीक आहे, इथपर्यंत कळलं? हो. ओके, आज थांबूया मग इथे.
हो चालेल.
ओके, उद्या कंटिन्यू करूया. आता आपल्याला भरपूर दिवस कंटिन्यू करायचं आहे.
हो नेक्स्ट वीक पण.
नेक्स्ट वीकपर्यंत. नेक्स्ट वीकमध्ये सुद्धा मॅडम म्हणलेत